Hello everyone. Let's talk a little bit about USB-C, power delivery, and there's something exciting is coming up that is so stale that not a lot of my friends even know about, but it might be something very beneficial for our open source DIY do-it-yourself community. Electronic, and that is what we call PPS, which is stand for Programmable Power Supply. So everyone know, quick charge power delivery 3.0 that you can request. So I have a page over here that open up. So if we take a look, standard power profile, you got 5 volt, 9 volt, 12, 15 volt, sometimes 12 volt, 20 volt. You got 3 amp. You can request 3 amp, 3 amp, 3 amp. 20 volt. You can sometimes request up to 5 amp. Depend on your power brick, right? So where is PPS standing in between any of these? So PPS stand for programmable power supply. So if you go to some of these newer charger, like these guy, right? You say 140 watt, blah blah blah. PD is new PD, but what you really want to see is when you type in PPS, it does have PPS fast charging protocol. And if you scroll down to the spec below, right, you can see that PPS allow you to request a voltage from 4 volt to 11 volt at 5 amp, or 4 volt to 21 volt at 4 amp. So this brick here has two variable power profile, right? And PPS usually you can request with an incremental of 20 millivolt. So there's another charger. It's from Ugreen, right? 140 watt. Also have you got PPS. Also have PPS, and this one only have one profile that you can use, and it can go up to 5 volt. Let me plug in my phone right now for charging, right? And it has super fast charging enable. You see that? And it's pulling, about 9 volt, so 60 watt, right? So 9 volt is one of the profile, right? You have a little bit of voltage drop because of the resistance of the cable, right? That's normal. So PPS exists because of this, right? Normally, you charge your phone. You have a DC, AC to DC converter from your USB-C wall charger down to whatever voltage you request. Let's say 5 volt, right? It will convert to 110 AC into 5 volt DC or 9 volt DC in this case of the phone. And then that 9 volt will transmit to a USB-C cable, go into your battery charge controller. This is part here is your phone. Go to DC-DC converter, maybe step it down to charge your lithium battery at 3.7 volt, right? And then eventually increase the output to the battery to 3.8, 3.9 until the battery is full, usually about 4.2 volt. But a DC-DC converter is like a bug, right? You have some efficiency loss. It can range from 80% all the way to 95%, which means you're gonna have 5% loss all the way to 20% loss, and that loss is going to be released as heat for your phone. And charging your battery, your battery heat up, and then you also have your charging circuit heat up. So if we can remove the heat, it'd be better for the phone, right? You have less heat source on the phone. So that's what when PPS come in. You will move that DC-DC converter from your phone to the charger. So now when I charge the battery, here's the battery. Let's say the battery voltage right now is 3 point. You need to charge it at 3.7 volt. You request 3.7 volt at the DC-DC converter on the wall, and then you just do a bypass right through. And then battery charge controllers monitor the battery current. If it needs some more, it just tell the wall charger to, hey, give me a little bit more voltage, give me a little bit more until the battery is full, and they just do cut off. So you completely bypass the DC-DC converter over here, and then you save that 5% to 20% efficiency in terms of heat. A lot of phone still have a DC-DC converter built in, but then have a bypass mode that you can bypass. A lot of device has that because what happened if you plug in a regular PD charge controller that doesn't have PPS. You need to have another way to charge the device. So some redundancy here. But what is the benefit if, as a DIY or electronic or electrical engineer, want to use this protocol into our product, like beside charging a device? Is there another way for us to use it? So if you pay close attention, you can see over here. If you request 5 volt, you capped out at 3 amp. You can't go more than that, right? If you request 12 volt, you cap out at 3 amp. But depend on the model of the charger. It can you say over here, if you're in this variable mode, you can request 5 volt and it can give you up to 5 amp. So that is more than a fixed voltage. Okay, that's all nice and cool. Okay, power delivery PPS is nice and all for charging phone, but how can a person that's a DIYer, a tinker, use it in their projects? So if you just want a fixed voltage, say 5, 9, 12, 20 volt, 15 volt, you can just go ahead and purchase something like this, a trigger board, right? It's gonna give you a fixed voltage regardless. So all you need to do is you might have to control switch. If you want to control the switch, you might have to have another buck converter, step down the voltage, from 20 volt to 5 volt, and then you run your microcontroller, and then convert your switch. So if a programmable board that already have a microcontroller would be an easier way for us to integrate everything in, right? We have a trigger board, we have a brain like a microcontroller, we have some switches that we control the output, maybe some more that we can hook up some sensor. Just a full-fledged package would be much nicer. So that's a board has been designed in the past. It's called PPS Micro. It's been designed by Ryan Ma. This board allows you to request any voltage you want, like I mentioned, 5 volt, 9 volt, regular PDO, fixed voltage, but he also make the board the programming so that you can actually request the PPS, so any voltage that you want. So if you want to have a variable voltage, instead of controlling PWM, if you have a resistor load, you can just use PPS to control the actual current going through by changing the voltage input. Right. The only problem with this is it's currently out of stocks, and I don't think he's supporting it anymore. You can see it's no longer available. So if we go back to the project page, you can see that it's using an ATmega as a microcontroller. So it's not very big. You can see that's 8K of flash and 1K of RAM. It's also used an IC is called FUS 302. Yeah, FUSB 302. The heavy lifting for the protocol had to be done on the microcontroller, so it's not a very easy IC to be used. So since I can't get it, it's out of stock, I can't get it. The microcontroller is slightly old, the chip is hard to use, so I set out to make another board that's an upgrade version of this, and I call this PicoPD. Pico because using the same form factor as Raspberry Pi Pico, and PD just stands for power delivery. And this board is an upgrade when you have an RP2040, our beloved Raspberry Pi Pico IC, and pairing with another USB-C negotiation board IC, paired with another USB negotiation IC, AP33772. Almost everything you want, just like Ryan Ma did, but it's much easier for you to program. So let me show you what this board can do. I'm going to turn my heads-up display. Here I got two board. I got one is our beloved Pico, right? Just Raspberry Pi Pico, normal, without the Wi-Fi. And then here you have the PicoPD board that have extra button. Here is a boot, it's a reset, so you don't have to unplug it all the time, right? And it has a USB-C instead of a micro USB. Now, so if I plugged it in right now, I believe it's pre-programmed to be 12 volt. Right. So let's see. Because I'm running on PPS right now, I can tell it to give me something else, like 10 volt. Take some time for this guy to update. Here I'm at 10 volt, and now I can do, let's say, 20 volt if I want to. And I'm based programmed through serial over here. It will eventually go to 10 volt. How can I go 6 volt? What happens if I want to go 6.4 volt? Here we go. The brick tend to give you a little bit of extra voltage to account for the drop when you start pulling current. So let's test the current. And by the way, I'm using this Ugreen 140 watt charger. This is SPD all the way up to 5 amp. Plug it back in. Alright, let's add. So you can see here, this is 8 ohm, 8 ohm, so in parallel that will be 4 ohm. And we can try do some current draw test. If I request 15 volt, you start to see the current start climbing up. You got some voltage drop across the cable, which is normal. If you want to compensate for that voltage drop, just request a little bit more voltage. Now I'm setting a request for 15 volt 0.5, and you see that it's giving slightly less because of the voltage drop. Now I can even do 20 volt, and I'm gonna pull very close to 5 amp. Yeah, so if voltage drop, it dropped down to 19 volt, and here I'm pulling current. So next video I'm gonna show you how to program this to Arduino IDE. So stay tuned.